Hi everyone. In this lecture, we're going to discuss the mesh analysis. So these are the features of mesh analysis. Mesh analysis is a useful network solving technique, and it is a combination of Ohm's law and the Kirchhoff's voltage law. So mesh analysis is basically clubbing of the Ohm's law and the KVL. Next, mesh analysis is applicable for lumped linear electrical networks only, same as the case we have studied in nodal analysis. Even nodal analysis is applicable for lumped linear electrical networks only. For distributed and nonlinear networks, the mesh analysis and nodal analysis both are not applicable. Mesh analysis is applicable only for planar circuits. What are planar circuits? The planar circuits are those circuits which you can draw in a two-dimensional plane. And nodal analysis, the last point is the nodal analysis and mesh analysis are independent to each other, as the KCL and the KVL are independent to each other. So these are the few features which about the mesh analysis. You have to remember, mesh analysis is only applicable to the planar networks. Next, what is a mesh? So there is a subtle difference between the definition of loop and mesh. A loop is a closed electrical path in which current flows. See, a loop is nothing but a closed electrical path. Any closed electrical path in which current flows, we call it as a loop. But there is a slight difference for the definition of mesh. A mesh is a loop which does not contain any other loops within it. So inside the mesh there are no internal loops. So mesh is the innermost loop. Understand? Now, if you look at this circuit which we have displayed, we can see this is one mesh and there is no inner loops inside this mesh. We are calling this mesh as 1, and similarly this is mesh 2 and mesh 3. So there are 3 meshes in the given electrical network. When you come to loops, see there are many loops. There are 7 loops in the circuit figure in the network shown. You can see here the outer is one loop, so it will count as a loop. And if you omit this one, this you can treat it as a, this is one closed path. There are 3 meshes and 7 loops, 7 closed paths. Next, the Kirchhoff's voltage law is applicable for both meshes and loops. Any closed loop, the Kirchhoff's voltage law, the KVL is applicable. But in mesh analysis, we only apply the KVL to the meshes so that the number of equations are reduced. So we can solve this network by only writing 3 mesh equations. So next, what is a planar circuit? As I told before, a planar circuit is a circuit that we can draw without any crossings in a two-dimensional plane. Even though the first figure, this figure is, you can see there are crossings here, but when you redraw the same circuit, you can see here there are no crossing. You can completely write the same circuit in two-dimensional plane without any crossing. So this is a planar circuit. So you have to be careful while deciding whether it is a planar circuit or non-planar circuit. Sometimes the circuit drawn in this fashion, you may imagine that it is non-planar, but you have to be careful to redraw it again as a planar circuit. Now here, this is a non-planar circuit. A non-planar circuit is a circuit which you cannot draw in a two-dimensional plane. So you cannot draw this one without crossings in a two-dimensional plane. So you have to remember that the mesh analysis is only applicable to the planar circuits. Steps for mesh analysis. The first step is identify the meshes in a given electrical network. Let us assume there are small n number of meshes in the given electrical network. Assign mesh currents I1, I2 -in n meshes. By applying the KVL in n meshes and by using Ohm's law express the voltages in terms of mesh currents. This is important. Express the voltages in terms of mesh currents, and you will get, for each mesh you will get one equation. So for n meshes you will get n simultaneous algebraic equations. By solving this n simultaneous algebraic equations, you will get the n mesh currents. The things which you have to remember while doing mesh analysis is that while assigning the currents in the meshes, all the mesh current direction should be in the same direction. That means if I1 is in clockwise direction, then I2, I3 and all other remaining mesh currents must also be in the clockwise direction. You cannot assign one current in clockwise, the other current in anti-clockwise direction. The usual practice used to choose clockwise current direction for the mesh currents. Next, while we traverse in a mesh, we assign positive polarity to the voltage rise. That means if you traverse from negative terminal to positive terminal, it is a potential rise. So we assign positive polarity for that voltage. When we traverse from positive polarity to negative polarity, it is a voltage drop. For voltage drop, we give negative sign. That you will understand in the example. Next, see this example here. In this example, the question is find out the branch currents capital I1, capital I2 and capital I3 using mesh analysis. If you carefully observe, here two meshes are there. This is mesh number 1. This is mesh number 2. So here what is the first step? We have identified the meshes and we are giving the mesh current variables as I1 and I2. Both the mesh current directions are in clockwise direction. The third step is we are traversing in the mesh direction. We start at this point and we go in this path. We traverse in this mesh in this fashion, and this is the complete traversal of the mesh. So when you traverse from this point to this point, you can see it is a potential rise. When you go from here to here, when you go from here to here, it is a potential rise. So for this we are giving positive polarity. So it is plus 15, and when you are traversing in this direction, current entering terminal is positive, current leaving terminal is negative. So here, what is the voltage drop across this resistor? The voltage drop across this resistor is 5 into I1. So this is positive and this negative. Since in our traversal we are moving from positive to negative, so it is a potential drop. For potential drop we give the minus polarity. In a similar fashion, when you come here, the current flowing in the clockwise direction is I1, the current flowing in the anti-clockwise direction is I2 across this 10 ohm resistor. So the net current that is flowing in our traversal direction is, that is in this direction, is I1 minus I2. So we are, and again it is a potential drop. Current entering terminal is positive, current leaving terminal is negative. So we are giving it as minus 10 into I1 minus I2, and again through this 10 volt source we are traversing from positive to negative, so it is a potential drop. So in this way you will get the mesh equation. If you simplify that, you are going to get 3I1 minus 2I2 is equals to 1. Next, if you apply the KVL to the mesh 2, again if you see, if you were traversing in this direction, so in this direction it is a potential rise, so positive symbol. Across this 10 ohm resistor, now in our current traversal direction the net current is I2 minus I1. So it is current entering terminal positive, it is current leaving terminal negative. So what it will become? It is a 10 into I1. Next, again it is a current entering terminal, current leaving terminal, so it is a potential drop, so minus 6I2, and through this one it is the current flowing is I2 minus 4I2. If you simplify this, you are going to get I1 minus 2I2 is equals to minus 1. So by solving these two equations, you are going to get, it is a simple algebraic, two variable algebraic equation which you can easily solve. You will get I1 as 1 ampere and I2 as 1 ampere. So from our observation we can observe this I1, this capital I1 and small I1 are same. The current flowing through the 5 ohm resistor is small I1. it is same as capital I1. So I1 is equals to capital I1 is equals to small I1. Similarly, capital I2 is equals to small I2. Now the current flowing through the 10 ohm resistor, that is capital I3, in this direction, what is the total current flowing through 10 ohm resistor? So in this direction it is I1, small I1. In this opposite direction it is small I2. So the net current in this direction, that is capital I3, is given by small I1 minus I2, so which is equal to 0 ampere. Next, the next case we'll see is mesh analysis with current source. So current source only in one mesh. This current source should belong to only one particular mesh, but it should not be common to the meshes. So in that case, one mesh variable is reduced. So that mesh variable can be directly computed just by observation, as in this case. So in the above circuit, I2 is equals to minus 5 ampere. Only I1 is the unknown variable, unknown mesh current. Next, case 2 is that if a current source exists between two meshes, that means it exists in a branch that is common to the two meshes, then we get something called as super mesh. So a super mesh results when two meshes have a current source in common. That current source can be dependent or independent current source. If you can see in this figure, there is a 6 ampere current source in a branch that is common to mesh 1 and mesh 2, then a super mesh is formed. So in analyzing the super mesh, see, now we cannot calculate the voltage drop across the current source in either this direction or in this direction. So what we do in super mesh analysis, we neglect this complete branch while writing the mesh equations, and we write the mesh equations with the mesh current variables excluding this branch. Now you will get the circuit. If you exclude this particular branch, your circuit will become like this. And if you write the mesh equations, what you are going to get? So we are traversing from this point to this point. So our traversal path is this one, like this, with the two mesh current variables. So first from here to here, it is potential rise 20 minus, what is the current flowing through the 6 ohm resistor? It is I1. So 6 I1 minus the current flowing through 10 ohm resistor is I2 minus 10 I2 minus current flowing through the 4 ohm resistor is I2 minus 4 I2 is equals to 0. So this is a super mesh equation, and this particular one is called super mesh. See, even though it appears as if the elements are connected in series, but you have to calculate the voltage drop by using the mesh current that flows through that particular resistors. Next, so you will get that equation. If you simplify this equation, you are going to get how much? 6 I1 minus plus 14 I2 is equals to 20. And there is one more relationship here which you can easily obtain. Now the current flowing in this path is I1, the current flowing in this path is I2. So the 6 ampere current will become what? The 6 ampere current is in the same direction of I2. So what you are going to get? So the net current that flows in this path is I2 minus I1, that is equal to 6 ampere. I2 minus I1 equal to 6 ampere. So that if you rearrange, you can write in this fashion, that is I1 minus I2 equal to minus 6. Because two variables are there, we require two relationships, two equations to solve the variables. If you solve these two equations, you are going to get I1 as minus 3.2 ampere, I2 as 2.8 ampere. So these values will substitute the equations. So if you compare the nodal and mesh analysis, both the nodal and mesh analysis provide a systematic way of analyzing a complex network. So which is a better one? So the choice boils down to a simple point. So if the number of nodes in a given number of principal nodes in a given electrical network are less, obviously you go for nodal analysis because it will give nice equations. If the number of meshes are less, you go for mesh analysis because the number of equations will be reduced. So the key is to select which method will result in lesser number of equations, and the second factor is how you can simplify the given network based on the information given. Thank you.